Hello everyone, this is Mr. Tanner, and this set of notes is going to look at the properties of atoms, how to read an element square, and then also the difference between an ionic bond and a covalent bond. Make sure you have your note sheet with you so you can fill it out as we go along. Let's get started. All right, let's start by looking at what are atoms. Well, atoms are the building blocks of everything that's known in the universe. Everything that we know of, from the piece of paper that you're writing on to the stars in the sky, are all made of atoms. And so far we know of 118 different types of atoms, that, as you'll see in a little bit, are organized in the periodic table of elements. All of the atoms are made up of the three same particles, and we call these particles subatomic particles. So first we have protons. They're depicted on the atom here in red. And protons are in the nucleus. The nucleus is the central structure of an atom. It's where all of the mass of the atom is located. And protons are in the nucleus, and they have a positive charge. It's also worth noting that they have a mass of 1, and it's just called an atomic mass unit. So their mass is 1 AMU. The number of protons also determines what type of atom we have. So every time you add a proton, you change the type of atom that we're looking at. 1 proton would be hydrogen, 2 protons is helium, 3 protons is lithium. Neutrons, which are depicted in this picture in the kind of dark gray, are also located in the nucleus, but they do not have a charge. They're neutrally charged, which means they have a charge of 0. However, neutrons also have a mass of 1 AMU. So if you have an element with 2 protons and 2 neutrons, each one of those has a mass of 1, so you get a total mass of 4 AMUs for a helium atom in this case. And then finally, depicted here in blue, we have electrons that would orbit the nucleus in shells, and they have a -1 charge. And while electrons aren't truly massless, they're close to 10,000 times less massive than a proton or neutron. So when we're totaling the mass of an atom, we just ignore their masses because they're completely insignificant. So for an electron, we would say that they have a mass of 0. All right, on this slide, we're going to go through how to interpret the information on an element square. And seen here, we have the element square of carbon. So let's first label what these different parts of the atom are. We have, I'm going to add a 0 here, and I'll tell you why in just a second. So first we have the element name, which in this case is carbon. This 0 would refer to the charge of the atom. So 0 would be neutral. You could have a +1 or +2 or +3 or -1 or -2 or -3. There's lots of different charges that an atom can have. If they're charged, we call them an ion, but if it's ever mentioned, it'll be in that top right corner for the charge of an atom. This top number here, the smaller of the two numbers, is called our atomic number. And as you'll see in just a second, the atomic number is the number of protons. So carbon has 6 protons. We have the element symbol. And then finally, the larger of the two numbers is the atomic mass. And the atomic mass is the combination of protons and neutrons in an element. So if you had 6 protons and 6 neutrons, you'd have an atomic mass of 12. This number is not quite exactly 12 because there's also carbon with 7 neutrons, which gives it a mass of 13, and carbon with 8 neutrons, which would give it a mass of 14. But carbon 6 is so much more common, or carbon 12 with 6 neutrons is so much more common, that if you were to average all of the masses of carbon, you would get 12.011 as the average mass. Next, we're going to show you how to calculate the number of protons, neutrons, and electrons given this element square. So first, to solve for the number of protons, all you need to know is the atomic number. The number of protons equals the atomic number. And remember, that's the smaller of the two numbers on that element square. Carbon's atomic number is 6. It has 6 protons. Nitrogen's atomic number is 7. Nitrogen has 7 protons. That's how we find number of protons. The number of neutrons, that equals our atomic mass. That's the larger of the two numbers, minus the atomic number. So for carbon, the atomic mass is 12, and the atomic number is 6, then there's 6 neutrons. 12 minus 6 is 6. If the atomic mass of carbon was 14, and their atomic number was 6, well, 14 minus 6 would give you 8 neutrons. So atomic mass minus atomic number gives you the number of neutrons. And finally, to find the number of electrons, you take the atomic number, the smaller of the two numbers, and then you subtract from that the element's charge. So in the case of the atom that I drew, or that was listed there, the carbon atom that I said was a neutral charge, a charge of 0, you would end up with 6 minus 0, which would equal 6 electrons. Often with oxygen, another element, oxygen often forms a negative 2 charged ion. So if we had 8 protons in oxygen minus the negative 2 charge, that would give us 10 electrons. Because if you subtract a negative number, you end up adding that number. So you can keep track of electrons by doing the atomic number minus the charge. Next, we'll take a look at the periodic table of elements to look at the two main ways that the elements are organized. So first, they are organized by atomic number. So as you can see, hydrogen has an atomic number of 1. Helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, and so on. As you go left to right, top to bottom, then the elements are just listed in order of the number of protons, of that atomic number. But that then begs the question, why is helium placed over here when there's room for it right here? And that brings us to the second way that the periodic table is organized, and that is by element property. And any element that's in the same column, so the same column, those elements tend to behave more similarly. And sometimes they even get group names. So we have here the alkali metals. The second column, number 2, we have the alkaline earth metals. Then we have some transition metals. We have noble gases over here, and these are all gases that don't react with other elements. They're inert is what we would call them, since we don't react. And since helium, which is number 2, is a noble gas, it doesn't react, they move it over to this column since it shares those properties. So if I were to ask you a question on a test, and I were to say what elements would have more in common, sodium and potassium, or sodium and calcium, you should know that the answer would be sodium and potassium because they are in the same column, whereas sodium and calcium are not in the same common. So elements that are in the same column tend to behave more similarly. They have more similar properties than elements that are not in the same column. And then the last thing we're going to look at in these sets of notes are molecules, which are atoms that bond together, and we'll also look at the two different main ways that bonds form, or how the atoms can combine. So when atoms bond or combine, they form molecules. So a molecule is anything with multiple atoms bonded together. And when these molecules form, the properties of the original atoms will change, sometimes really dramatically. So as a couple of examples, a water molecule is 2 hydrogen atoms bonded to 1 oxygen atom. And hydrogen and oxygen are both gases at room temperature and standard pressure, but when they form a molecule together, they are a liquid at room temperature and standard pressure. So they've changed their properties. Perhaps even more dramatic is sodium, which is an alkali metal that is very, very reactive. If you put pure sodium in water, it will catch on fire and begin moving around and can sometimes make loud pops as it's releasing its energy and forming hydrogen gas. So sodium is very, very reactive. Chlorine is a chemical weapon of a gas. It is banned in warfare. It's so dangerous. But if you bond sodium and chlorine, you get table salt that you might put on French fries. So this dramatically changes the properties when these two elements react. Or I should say bond to form a molecule. And then finally, let's look at the 2 different types of bonds that atoms can form. The first is an ionic bond. And ionic bonds form when one atom fully captures the other atom's electron. And in that case, it makes each atom an ion. Each atom becomes charged, hence the name ionic bonds. The second type of bond is a covalent bond. And this forms when the atoms and the molecules share their electrons between them instead of stealing an electron from the atom. So I'm going to draw a couple of pictures to help you visualize the 2 different types of bonding that can happen. We'll start with ionic bonds. Remember, this is taking electrons. And we'll look at salt. We'll look at our salt example. So when we have sodium, sodium is an atom that has 11 protons, 11 neutrons, and 11 electrons. And we're just going to draw the electrons. Electrons exist in orbitals or shells. The innermost shell can only hold 2 electrons. I'll draw them in blue to help keep track. So the first shell can hold 2 electrons. And when an electron shell is full, that atom doesn't want to react. It becomes way more non-reactive than if the atomic or the electron shell is not full. So the first one is full when it holds 2 electrons. The second shell can hold up to 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons plus 2 electrons gives us 10, but we know there's 11, so we need to draw one more shell. And that means that in sodium, the outermost shell of electrons only has 1 electron, and that is a very reactive state to be on. That's not a very stable configuration, which is part of the reason why sodium is very reactive. And then on the other side here, we can draw chlorine. Chlorine has 17 protons. It has usually either 18 or 19 neutrons. Both are very common. And we'll have 17 electrons. So we'll draw our shells. In the first shell, we have our 2 electrons. In the second shell, we have 8. 2 plus 8 is 10. 17 electrons minus 10 leaves 7 more. So in the outermost shell, we have 1, 2, 3, 4, 5, 6, 7. And we know here again in this third shell that an 8th electron will make this element way less reactive. 8 electrons in the outermost shell are stable. If the sodium gets rid of an electron, its outermost shell, which is the second shell, would then also have 8, and it would be stable. So when sodium and chlorine get close to each other, chlorine captures that electron from the sodium. So once it's captured that electron, we can get rid of this outermost shell. And we now have a sodium molecule That's the outermost, only has 10 electrons now. It has 10 electrons that are negatively charged. It has 11 protons. 11 positive charges minus 10 negative charges gives this sodium now a charge of +1. It has become an ion. This chlorine, which captured the electron, now has 18 electrons and only 17 protons, which gives it a charge of -1. Both atoms have become ions, but opposite charges attract. Just like the north and south pole of a magnet are bonded together, a positive charge will stick to a negative charge. So there's an electrical force that now bonds this chlorine and sodium together. And that's how you form an ionic bond. It's that connection between a positive charge and a negative charge that happens when an electron is stolen, and it creates two ions. Now, alternatively, with covalent bonds, again, this is sharing. We don't completely capture an electron, we end up sharing them. So the example here could be with oxygen. Oxygen has 8 protons, 8 neutrons, and 8 electrons. So in the first shell of electrons, oxygen has 1, 2, that makes it full. In the second shell, there's 6 electrons available left. So oxygen has 1, 2, 3, 4, 5, 6. 6 plus 2 is our 8 electrons, and that's 2 away from full. If it had 2 more electrons, that outermost shell would be full, and oxygen would be in a much more stable configuration. So what will often happen is that hydrogen gets nearby. Hydrogen only has 1 electron, and if they get close, it will share that electron. So if you look now on this ring, there's 2 electrons for hydrogen, which gives it a stable configuration. And oxygen now has 7 electrons that it can use. So if a second hydrogen comes along and shares its electron as well, now both hydrogens are stable, and the oxygen is also stable with those 8 electrons. That only happens through sharing. So when they've shared these electrons, you can also bond them by the electrons themselves. And this is a covalent bond. Hopefully these drawings help you visualize the difference between taking an electron and sharing an electron. But for the purpose of a test, all I would ask is what type of bond shares electrons between the atoms, and you should know that's a covalent bond. Or I could ask what type of bond takes an electron from one atom to another, and you should know that that is an ionic bond. But hopefully these drawings help. And as always, thanks for watching the notes. If you have any questions, make sure you reach out and ask.